Hey math fans, we're on section 6.6.1. Let's get started. Welcome to Unit 6. It's entitled Coordinate Geometry, which is the overlap between algebra and geometry. We spent a lot of time talking about how two objects can be congruent, but now we're going to prove that they are the same size and shape using algebra. One of the big things that we're going to take from geometry and use algebra to prove is this idea of Pythagorean theorem to find the distance between 2 points. So how do you calculate the distance between 2 points? Well, it's pretty easy if it's horizontal or vertical, but if it is not horizontal or vertical, we're going to use this thing called the distance formula. So what is the distance between 1, 2 and 5, 5? Unfortunately, we can't just add the diagonals and come up with some sort of distance there. We're going to have to consider Pythagorean theorem in order to find the hypotenuse of a right triangle. In this particular problem, we are traveling 4 units to the right and then 3 units up, making a right triangle. According to Pythagorean theorem, to solve for c, the hypotenuse or the distance, we would say 4 squared plus 3 squared is equal to c squared. And then we just solve for c. 4 squared is 16, 3 squared is 9, square root of 25 is 5. So the distance between these 2 points is 5. The distance formula is derived from the Pythagorean theorem. If we have 2 points, x1, y1, and x2, y2, all we have to do is figure out how many units are between x1 and x2, which is just the difference between those two, and how many units are between y1 and y2. Notice I have absolute value symbols because it is distance, but when we're using Pythagorean theorem, we do not need to worry about the absolute value because we're going to be squaring those numbers anyway. So however you look at it, A is going to be x2 minus x1. B is going to be y2 minus y1. We're going to square those and then take the square root for the distance. So what is the distance formula? It's based off of the Pythagorean theorem, and all it is x2 minus x1 squared plus y2 minus y1 squared, and then a big square root over the whole thing. And it comes from Pythagorean theorem. What about slope? To find the slope, remember we use the slope formula, which is y2 minus y1 over x2 minus x1. It's based off of the change in y over the change in x. We talked about this when we were discussing rate of change. Sometimes we might actually have to plug in the x values into the function to get those y values. Where are we going to use the slope formula? Well, it's going to be used to prove that 2 lines in a figure are parallel. Maybe we're trying to prove that something's a parallelogram. Well, if we actually know the equations of those lines, we can just look at the slopes. Parallel lines have the same slope. So if you take a look at these 2 lines, they both have a slope of positive 2. Perpendicular lines have what are called opposite reciprocal slopes. In other words, if we were to multiply both of these slopes, we would get a value of -1. The first slope is 3 over 4. The second slope is -4 over 3. Multiply those together, you get -1. These 2 lines are perpendicular. Here are some common errors and misconceptions. Example 1, calculate the distance between the points 4, 9 and 2, 6. I need you showing all your work when you're doing the distance formula. Notice how I've substituted in x2 minus x1, y2 minus y1. You get square root of 45. And of course, we know that we can simplify radical 45 into 3 radical 5. Example 2, determine if the line through the points -8, 5 and -5, 3 is parallel to the line through the points 1 comma 3, and 4 comma 1. First line, once substituting the numbers into the slope formula, we get negative 2 over 3. For the second line, we get negative 2 over 3 also. So therefore, we can conclude that the two lines are parallel because they have the same slope. If these numbers do not match exactly, they are not parallel. You might ask yourself, hey, do these things look parallel? Or in this case, plot these points and see if they look perpendicular, but it's not how they look, it's what the math tells us. We're going to be proving whether or not these lines are perpendicular or parallel. Again, how do you prove it? You do the calculations, you show all the work, and you follow the rules. And in this case, we're going to see if both of these lines have opposite reciprocal slopes, or when you multiply them together, their product is negative 1. So we need to use the slope formula and show all our work. This is the slope formula for the first set of points, and we get 1 over 4. This is the formula for the second set of points, and we get negative 4. And the question is 1 over 4 times negative 4 equal to negative 1? The answer is yes. So since the product of the two slopes is negative 1, that means they're opposite reciprocals, and therefore the two lines are perpendicular. Again, it's all about proving these lines are perpendicular and parallel. It's proving that the distances are equal. So whenever I say the word prove, and we're going to use what's called a geometric proof, I'm going to want to see all of this work. For example, prove this is a right triangle given these coordinates. Well, the first thing you'd want to do is draw the picture. And then I would try and ask myself, where do you believe the right angle would be? And it looks like the right angle should be right here. So it becomes a matter of, can I prove that AB is perpendicular to BC by using the slope formula? After figuring out the formula for AB and BC, we can see that both slopes, negative 2 and 1 over 2, are opposite reciprocals. In other words, when I multiply both of these slopes together, I get negative 1. And now I can say for sure that those two line segments are perpendicular, and therefore, I don't know if you've ever seen this symbol before, therefore is the 3 dots. This is triangle ABC is a right triangle. Example 5, prove that this quadrilateral ABCD is a square. If I'm going to prove something's a square, I got to show all the sides are congruent and all the angles that are right angles. That's the definition of what a square is. How am I going to do that algebraically? What's the proof I'm going to show you? Well, I'm going to graph all the points first. Then I'm going to use 4 distance formulas between all of those 4 line segments, AB, BC, CD, and AD, with all my work shown, and I'm going to show you that all 4 distances are equal. Then I'm also going to have to show you 4 slope formulas, the slope between AB, BC, CD, and AD. And if they are opposite reciprocals or their products equal negative 1, I will have proven that this is a square. This is what's called a coordinate geometry proof, and we're going to do quite a few of these before the end of the unit. And that's going to do it for this section. We'll see you in class.